This week, something unusual happened at Tesla's Giga Texas factory. Production of both the Model Y and Cybertruck reportedly came to a complete stop. There were no announcements of supply issues or labor disruptions, which has led many to believe the pause was intentional. Construction activity on the north side of the plant has been noticed, along with what appears to be a reconfiguration of the assembly lines. This could be a signal of preparation for an entirely new vehicle, possibly the long-rumored 2026 Tesla Model 2. As this EV has always been part of Tesla's long-term development path, we're still planning to release models this year. It's actually not just a revolution in vehicle design, but a revolution in vehicle manufacturing. Priced at just $10,179, the Model 2 is expected to be Tesla's most affordable EV. Yet could this sudden shutdown be Tesla clearing the path for its most disruptive product to date? And could a compact, low-cost EV really become the most important car in the company's history? If the rumors are true, what we're seeing might not just be a production pause, but the quiet beginning of something massive. Before we get into the details, don't forget to subscribe to subscribers. 1. How did Elon slash the price nearly in half without cutting quality? Leaked photos taken near Tesla's Fremont facility recently revealed a heavily camouflaged vehicle covered in black fabric. Despite the attempt to conceal its identity, its size was unmistakable. The vehicle appeared noticeably shorter than both the Model Y and Model 3, with a sloped front profile and tighter dimensions between the front axle and the front door. This gap measures just 0.8 m on the Model 2 compared to 1.22 m on the Model 3. While it may appear insignificant, this 33% reduction reflects a major shift in vehicle architecture. It signals a compact, denser platform specifically designed to reduce waste material use and overall production complexity. Underneath that sleeker exterior lies the real game. Share Tesla's next-generation unibody Giga casting system. Instead of assembling dozens of individual metal components to form the vehicle's chassis, Tesla now produces the front and rear underbody structures as single aluminum castings. In the Model 3, the chassis requires over 70 structural parts, whereas the Model 2 is expected to use fewer than 38. That's a 47% reduction in part count. Fewer parts mean fewer welds, fewer machines, and less room for manufacturing error. This streamlined process significantly improves reliability while lowering both labor and equipment costs. As a result, Tesla has cut assembly time per vehicle by an estimated 63%, while it takes competitors like Nissan and Chevrolet approximately 25 to 30 hours to fully assemble a compact EV. Tesla aims to complete the Model 2 in just 11 hours. This level of efficiency leads to over 30% lower labor costs per unit and dramatically increases production output. It is a key factor in Tesla's ability to offer the Model 2 at a starting price of around $10,179 while still maintaining profitability. Equally impressive is the increase in energy efficiency. The Model 2 is projected to consume only 109 Wh per kilometer, whereas many EVs in its class, including the Nissan Leaf and Chevrolet Bolt, typically use between 145 and 60 Wh per kilometer in real-world driving. This efficiency means Tesla can achieve comparable or even better range using a smaller, less expensive battery pack, which further reduces costs across the board. To put things in perspective, the Chevrolet Bolt EUV starts at around $27,000 and offers $259 mi of EPA-rated range. Using a 65 kilowatt-hour battery is estimated to include nearly 10,000 individual parts. In contrast, the 2026 Tesla Model 2 will start at approximately $10,179 and is expected to offer between $295 and 315 miles of range in its base version, with an optional upgrade extending that to around 350 miles. Tesla's goal is to assemble this vehicle with fewer than 5,500 parts, effectively cutting production complexity in half. Will other automakers follow Tesla's 11-hour assembly strategy? Comment yes if you believe this could soon become the new manufacturing standard. 2. Why is a 0.6 m rear door the ultimate urban advantage? Tesla's Model 2 features a rear hatch opening width of just 0.6 m, which may seem modest at first, but it is expertly optimized to maximize cargo capacity, delivering 400 L of usable space. To put this into perspective, the Model 2's cargo volume surpasses popular urban EV competitors such as the MG4, which offers 363 L, the Fiat 500e at 185 L, and the Mini SE with 211 L. Despite having a narrower hatch, Tesla's clever design balances a compact rear profile with maximum practical storage, proving that bigger openings don't always translate to better utility. In Real-world use. This design offers significant advantages. Tesla drivers enjoy a 96% success rate when parallel parking in tight urban spaces, which is 22% higher than the average 74% success rate for typical compact electric vehicles. This means fewer parking struggles and less stress navigating crowded city streets. Tesla owners also experience 83% fewer door dings in tight parking lots thanks to the narrower door width and ultra-thin, high-strength door panels. Dents and scratches caused by neighboring vehicles or cramped parking conditions are dramatically reduced, lowering repair costs and keeping the car looking new longer. Additionally, accessing cargo in underground garages is 22.7% easier with the Model 2's narrower rear door opening. Many underground garages have tight parking bays and limited clearance, so this design simplifies loading and unloading without risking bumps or scrapes. Tesla achieved these urban-friendly benefits through innovative engineering. The door panels use SpaceX-graded ultra-thin high-strength steel that is 18% thinner than typical automotive standards. This saves space without compromising strength or safety, allowing the door to be both slim and durable. Compact hinge mechanisms were specifically designed to maximize the usable opening width within a smaller frame. These hinges take up less space and allow the door to open fully without requiring a wide swing radius, ideal for cramped parking spots. Furthermore, the rear seats fold flat with a single motion operation, allowing the cargo space to expand quickly and easily. This feature transforms the compact hatch area into a versatile load floor capable of handling larger items. Obviously, Tesla's 0.6mm rear door is far more than a space-saving feature. It is a purpose-built engineering solution tailored to the realities of urban living, making parking easier, cargo handling smoother, and city driving less stressful, all while maintaining the flexibility and utility that modern lifestyles demand. 3. Why is the Model 2 becoming the #1 dream car for the forgotten corners of America? Tesla's Model 2 is equipped with free built-in Starlink connectivity, a groundbreaking feature that normally costs consumers $99 per month for service, plus an upfront hardware cost of around $499. This connectivity is not just a luxury, it addresses a critical issue affecting over 26 million rural Americans who currently lack reliable broadband internet access. For these communities, limited or no internet connectivity creates significant barriers in education, healthcare, work, and daily communication. By integrating Starlink directly into the Model 2, Tesla transforms the vehicle into a rolling digital lifeline capable of delivering high-speed satellite internet wherever the car travels. This built-in connectivity allows the Model 2 to serve as a versatile remote work hub,